Okay, so here we have number 11. The carousel at the fair makes 3 revolutions per minute and operates for 4 minutes at a time. Write an equation and complete the function table that relates the input in minutes to the output in revolutions. Then plot the numbers on a coordinate plane and draw a segment for the length of a ride. Okay, so I want to take a step back here so we can remember the basics of what we're doing. For those of you who are starting to get a little confused. Remember, we have our function factory. Our function factory has to have an input and an output. Our input in this case is our minutes. Our output is how many revolutions we get to have. And they're telling us that at the fair, we get 3 revolutions per minute. So as we put in our minutes into this factory, 3 is our constant, 3 is our rule, and then out comes our number of revolutions. So we can create a direct variation, a function, and we get, and it would look like this because this is our y every time, this is our x every time, and this is our constant. Oops, this is our constant every time. So it would look like this. Y equals 3x. Or in this case, they want us to use R equals 3m. They want us to use R and M for revolution and minutes. Okay, so if it has been 1 minute, then there will be 3 revolutions. 1 times 3 equals 3. If it has been 2 minutes, there will be 2 times 3 equals 6. Then there will be 6 revolutions. If there has been 3 minutes, 3 times 3 equals 9. Then we'll have 9 revolutions. And then remember, it says that it's going for 4 minutes. So we add in 4 over here. 4 times 3 equals 12. And now we have our last part of the function. And you can put 3m up here. Now we can graph. And here we have our minutes. Notice how our x and our y is set up for us already. Our input is always our x. Our output is always our y. So we have 1 and 3, 2 and 6, 3 and 9, 4 and 12. And there's our graph. We can connect the dots. And we have successfully drawn our function of the carousel, and it is a direct variation. It follows the pattern of our equation and our graph. It goes to the origin, it goes upwards and to the right, and it is a straight line. So we've talked about direct variations, and now we're going to talk about inverse variations. Okay, this is kind of the opposite. So remember with direct, we had as one increased, the other increased, or as one decreased, the other decreased. Well, with inverse, we're going to see as one increases, the other decreases. And this is an example. Adam is taking a 120-mile trip. The faster he drives, the shorter the time it takes to get there. The variables are the speed or rate and the time. The distance does not change. The distance is the constant, right? So say you're going on a trip, the distance doesn't change. It's going to take the same amount of miles to get from one location to another location. Like when you're going to school, right? The distance from your house to the school doesn't change. So you have rate times time is going to equal your distance. Maybe you're running late one day, and so you go faster, so the time is going to decrease. Your rate is going to increase, so your time decreases. The distance is the same. Or maybe you've woken up early, and you're kind of just taking a slower pace, enjoying the scenery, and so your rate has decreased, and now it's taking you longer to get there, so your time has increased. But that distance between your home and school is the same. In an inverse variation equation, the variables are multiplied and the product is constant, right? So here we're multiplying these variables to get our constant product. So here's 2 hours times 60 miles per hour equals our time times 40 miles per hour. To get a new time. Well, 2 times 60 gives us 120 equals t times 40. We know that 3 times 40 would give us 120, so t equals 3 hours. So now let's move on to 13, 14, and 15. We're using that equation that we just did for this, to look at this. Rate times time equals 120. So we're going on a 120-mile trip. This is our inverse variation equation, where 120 is our constant and rate times time are our variables. Our rate and our time are our variables. Our time being x and our rate being y. So it says multiply each pair of the numbers in the table. Well, before we do that, let's go up here and fill in our table. Okay, so notice how 60 times 2 gives us 120. So we have to fill in the rest. We just did 40 times 3, so let's fill that in. Well, 30 times what is going to give us 120? Well, 4. And then 20 times what is going to give us 120? 6. So we filled in our table, and as we multiplied each one of these, we found that the products are equal, right? All of these products are equal to 120. Now they want us to graph the pairs of numbers in the table. Notice the points are not aligned and that 0, 0 is not a solution pair for the function. Okay, so let's do that. Let's graph 2 and 60. So at 2 hours, we've gone 60 miles per hour. At 3 hours, we've gone 40 miles per hour. At 4 hours, we've gone 30 miles per hour. And at 6 hours, we've gone 20 miles per hour. Okay, so you can't see it very well on here, but when we connect the point, it is a curve and not a line. We're never going to be over here at 0, 0. It's never going to be a solution. Our inverse variation is going to be a curve and never a line. Okay, so let's look at another example of an inverse variation. It will take 48 person hours, so 48 hours of a person working to roof the whole house. So if we had 2 people, it would take 24 hours to roof the house, because 2 people times 24 hours equals 48 person hours. So if we had 3 people working, the job still takes the same amount of work, 48 total person hours, but it will take less time because there are more people working. 2 people times 24 hours would equal 3 people times how many hours? So let's create an equation. 2 times 24 equals 3t. We know this is 48 equals 3t. Divide both sides by 3. 48 divided by 3 gives me 16. So 16t. So it will take 16 hours if I have 3 people working. If 3 people can harvest the field in 8 days, how many people are needed to harvest the field in 2 days? Okay, so here we have another equation. If I have 3 people times 8 days, how many people in 2 days? Okay, so this is kind of ugly math grammar, right? Let's clean it up. Okay, 3 times 8 is 24 equals 2n. Okay, let me divide both sides by 2. 12 equals n. It will take 12 people to harvest the field in 2 days. Okay, so one really cool thing about these inverse variations is that it can help us multiply numbers mentally. If I have 24 and 15, I can take half of 24 and double 15, and that gives us 12 and 30 to get 36. So mentally find the product of 25 and 18. Double 25 and take half of 18. Well, if I double 25, I get 50. And if I take half of 18, I get 9. So 50 times 9 is 450. Okay, so we have completed the investigation. I want you to take pictures of each page of the investigation that you've completed. Hopefully you've been able to complete it on the actual worksheet. If not, you've done it on a lined piece of paper. Take pictures of each page, upload it to the here, add or create button, and then once it has all been uploaded, you can mark as done. That's all you have to do for this investigation, and I will see you later. Bye.